This is Isaac Newton, one of the greatest scientists of all time. Newton came up with the three fundamental laws of motion which form the fundamentals of physics and classical mechanics. For his efforts, he was made a knight by the Queen of England. And for nearly 250 years, Newton's laws were undisputed, until in the 20th century, when Einstein came along with his theory of relativity and broke down Newton's laws when approaching the speed of light. But for the more general case of velocities lower than the speed of light, Newton's laws hold true to this day. I will be demonstrating Newton's two laws using a robotic ball known as a Sphero, which is basically a new age remote controlled toy and is controlled through Bluetooth by a smartphone, which in this case is an iPhone. The basic science behind how a Sphero works in the same way that is behind a Segway, a hamster and a ball. They are all based on Newton's laws of motion. And by the way, rocket science is also based on that as well. So as I said, the Sphero is kind of like a hamster in a ball. The hamster runs up the side of the ball, but on the inside it doesn't get very far. Gravity pulls it down, and as the weight tips down, the ball rolls, and the process repeats. In the case of the Sphero, the brain of the hamster is the phone that controls it, the legs are the two wheels, and the muscles are the electric motor that powers the wheels.
Now let's start with Newton's first law of motion. Newton's first law, aka the law of inertia, states that a body at rest continues to stay at rest, and one that is in a state of uniform motion will stay in that state of motion unless an external unbalanced force acts on it. This is easy to demo with the Sphero. The ball will remain at rest unless it is acted upon by an external force, which in this case is torque from the motor. Once a force acts on it, it will keep moving until it hits in the same direction until it hits an obstacle, which in this case is a wall. In reality, because of friction, it will slow down, but because the motor is applying an opposing force to balance the friction, it keeps going at a steady pace. Then it hits the wall, which acts as an external force and stops. On to Newton's second law. Force equals mass times acceleration. Force is appropriately measured in the unit newtons. To accelerate an object of greater mass, you need greater force. Attaching a special chariot I built out of K-Nex to the Sphero and having it pull a light load, Sphero does a good job even with the motor not running at full capacity. But if we increase the load it is pulling without increasing force from the motor, this Sphero is going nowhere. However, if we increase the force, voila, the Sphero is able to pull the load. Therefore, you need more force to pull more mass for the same acceleration. Newton's third law. All actions have an equal and opposite reaction. The only way Sphero is able to roll is because of the third law. The wheels inside Sphero, right here and right there, are acted upon by rotational force, also known as torque, which is applied by the motor. This makes the wheels apply backward force on the Sphero shell. The shell then applies an equal and opposite force on the wheels, causing them to move forward and the entire ball roll. Finally, Newton's third law. All actions have an equal and opposite reaction. The only way Sphero is able to roll is because of the third law. The wheels inside Sphero, right here and right there, are acted upon by rotational force, also known as torque, which is applied by the motor, this entire bottom part. This makes the wheels apply backward force on the Sphero shell. The shell then applies an equal and opposite force on the wheels, causing them to move forward and the entire ball roll. Basically, the wheels are pushing backwards on the ball shell, and the ball pushes back, but in the opposite direction, which allows the entire sphere to move.
We have reached the end of our lesson. Newton's 3 laws can be found everywhere in nature and around the world. But just remember, this guy is one of the greatest scientists of all time.